Hi there. Today we're going to be looking at the law of cosines. We've spent a lot of time talking about using the law of sines to help us solve triangles that don't have a right angle. And we were able to use the law of sines for 3 different cases. We were able to use the law of sines to help solve for triangles when we were given 2 angles and a side, either by angle, side, or angle, side, angle. And then there's that special case, that SSA case that we have to make sure that we're super cautious about. But we're not always able to use the law of sines. For example, if we look at our information that we're given in example 1, we have side A, side B, and angle C. In order to use the law of sines, we have to be able to set up a ratio, right? We have to be able to set up one of the sides over the angle opposite that side. And so if we look at that, there isn't one. And sometimes that was true in the law of sines, but we were able to use the triangle sum formula to find the third angle for us to be able to put that in a ratio with one of the sides, and that's not the case here. So there are some cases where we can't do that, and those are the side angle side cases like we have in example 1, and also the side case. And so this is a new formula rule that we're going to be looking at, and it's called the law of cosines. For triangle ABC with side lengths A, B, and C, we could write it like this, that A squared equals B squared plus C squared minus 2BC times the cosine of A. Notice that we have A squared and we have the cosine of angle A. So that's kind of where our matching pieces are, okay? Another iteration of the law of sines is if we have B squared, we can say that equals A squared plus C squared minus 2AC times the cosine of B. Again, we have this B squared on one side, and then we're taking the cosine of B there. So let's write what we think it might be for C squared. If we have C squared, obviously we're going to be dealing with the cosine of C, and then we'll have to deal with the other 2 sides. So that's what happens in these spots, is that we use the other 2 sides. So if we're using side C and angle C, that means that we're going to be using side A and side B, so A squared plus B squared, then minus 2 times the product of those 2 sides, A times B, times the cosine of C. Now I know this looks like a lot, but I promise after you use it for a bit, it won't be too bad. And especially because we've become so comfortable with the law of sines, sometimes we get comfortable and we want to use the law of cosines, and then people are like, well, I'm gonna go and use the law of sines now. You have to be careful, all right? There are some special rules to keep in mind if you use the law of sines. If it's an SAS case and you're given an acute angle, after you find the last side, you have to use the smaller side. Make sure you use the smaller side to find a small angle. Because as we've seen, the issue with the law of sines is that it doesn't give obtuse angles. So we wouldn't want to use the law of sines to try to get an obtuse angle. Now, and that's the thing, you might say, well, what about a second triangle? Well, in SAS and SSS cases, there is only one triangle. So you'd be doing all this extra work for nothing. And then if it's side, then you find the largest angle first using the law of cosines, because the law of cosines would find an obtuse angle, and then that way you're not maybe finding an obtuse angle with the law of sines. That's a lot to remember, okay? And I know that you guys like the law of sines. Well, I think you do. But I have this written in case you're going to be stubborn. But I'm going to ask you just to cross all those rules out. That is too much to remember. We have too much going on in our world. What we're going to do is that once we use the law of cosines to start, we're going to stick with the law of cosines. Using the law of cosines throughout is going to be safer, because that way the order in which you find the missing pieces won't matter. It's ultimately up to you. But let's trust Mrs. Mackey here, and all your other Algebra 2 trig teachers often say the same thing, okay? So I know it looks like 3 formulas. It's not. Again, it's the side and the angle are here, And then we've just got that pattern using the other two sides here. We'll practice it, okay? So example 1 says we want to solve triangle ABC. And again, we have A is 22, side B is 15, and the measure of angle C is 108. We know we can't use the law of sines because we don't have a ratio to set up. So let's use our law of cosines. Now, how do you know which one to use? Well, we have this angle C, right? So when we have angle C, then that means we're going to want to use the side C. So we'll use the one with side C. And it doesn't hurt to write out the formula when you're using it, especially the first day, all right? So I'm going to need the other two sides. So it's going to be a squared plus b squared. Okay. Now minus 2, and then use those sides, a times b, and then times the cosine of angle C. All right. And now we just fill in, right? So let's fill in what we can here. We don't know C, but I know that A is 22. I know B is 15. Again, A is 22, B is 15, and I know that angle C is 108 degrees. Now, the nice thing about this SAS case is that, do you notice that we don't have to really do a lot of work to isolate C, that all the numbers are on one side of the equation? So what's nice about that, again, just make sure your calculator, oops, see, I gotta change it, is in degree mode. Sorry about the blue rectangle, as we're gonna just punch that in. So 22 squared, and because my numbers aren't negative that I'm squaring, I'm just not gonna put the parentheses in, okay? If they're negative, we would need the parentheses around those. But 22 squared plus 15 squared minus 2 times 22 times 15 times the cosine of 108. And that gives me about 912.95. Now, even though I'm writing 912.95 down, don't clear your calculator. Keep this in here, okay? Now, this is C squared. That's not C. What would we need to do to find C? Of course, we'll take the square root. And so what we can do is, especially if we have the graphing calculator, to find the square root, you can do second and then square root. And then remember that above the answer key in the graphing calculator, above the negative key in the graphing calculator, there's the answer thing. So if you hit second and then negative, what happens is it'll take the square root of that specific answer. I think that's a nice thing. We don't want to take the square root of 912.95 because once we start doing operations with rounded answers, it's going to be a hot mess, okay? So anyway, let's round the final answers to the nearest 10th. That'll give me about 30.2, okay? So there we have it there. Now I know, again, it's tempting to use the law of sines, but let's keep practicing and use the law of cosines again. So let's use the law of cosines, and this time you get to pick. You can decide. You're like, okay, well, I could either use A or B, and I guess A comes first, so why don't we just use A, all right? So again, let's use the one with A squared. A squared equals, we'd have the other two sides, B squared plus C squared minus 2 times those two sides, and then times the cosine of angle A. And let's put those in. A, again, it told us was 22. B was 15. And we do have to use a rounded answer here, I know. C is about 30.2. And because we're rounding to the nearest 10th, our answers probably are gonna not be perfect. Oops. But we'll deal with it for now, okay? So 2 times B, which is 15, times C, which we said is 30.2, times the cosine of A. All right. Now, what I have a lot of kids do, don't be this kid, okay? I have a lot of people say, oh, I need to find cosine of A. I'm going to take all of this and then divide. That's a super bad plan. The reason it's a super bad plan is because that's like not legal, okay? that's not the coefficient of the cosine of angle A. If you look, like this is making me nervous. If you look, the only coefficient of angle A is this part here, like is this -2 times 15 times 30.2. That's the coefficient of angle A, you guys. So that means that you have to move these other terms over before you start doing this division stuff, okay? So let's move those over. You're going to be fine. 22 squared minus 15 squared minus 30.2 squared, and then equals, I have -2 times 15 times 30.2 times the cosine of A, okay? And so at this point, now I'm okay with you putting stuff into the calculator. If you're feeling, if you're feeling pretty confident, you could, write all of this over that. Like you could write it as 22 squared minus 15 squared minus 30.2 squared, and then all over -2 times 15 times 30.2. Just make sure that you put all of that in your calculator first. That's kind of what I'm anxious about here. Okay. So let's put this into the calculator. Let's put 22, come here, 22 squared minus 15 squared minus 30.2 squared. Oh, I didn't square it. 22 squared minus 15, wow. Minus 30.2 squared. Okay, that gives me about 653.04. And then I can multiply these together. -2 times 15 times 30.2. That gives me -906. Okay. And then hopefully you see that to find the cosine of A, we would need to divide -653.04 by -906. And I get here about -0.721. And I'm rounding, and that is the cosine of A. Now, our goal is to find angle A. If we want to find angle A, I have to get rid of the cosine. And to get rid of the cosine, what does that mean I have to use? Inverse cosine. So what I want to do is really take the inverse cosine of this answer. So if I take the inverse cosine of cosine A, I get the measure of angle A. Okay. And I want to take the inverse cosine of this. But again, please don't type in 0.7121. Take, use second, what am I doing? Oh yeah, second inverse cosine. So second cosine for inverse cosine. And then second negative to give that answer. And then that gives me about 43.9 degrees if I'm rounding to the nearest 10th. If I took inverse cosine of 0.721, okay, you get the same thing. But do you see how it's a little bit different if you round to the nearest 10th? But do you see how it's a little different? And maybe your rounding would have been off. So just always use the answer to be safe, guys, okay? Now, the last thing we need to do is we have side C and angle C. We have side A and angle A. The last thing we need is angle B. And as much fun as we're having with this new law of cosines, wouldn't it make us the most sense to use the triangle sum theorem? So to find the last angle, we could take 180 minus angle C, which was 108 degrees, minus 43.9. And that gives us 28.1. So the measure of angle B is about 28.1 degrees. Okay? So one of the most important things I can stress is the idea of going from, going from this step to this step. That's really important that you don't think that all of this is in front of the cosine of A. I'm getting chills thinking about it, okay? Model your work for this next U-try question after what we've done in example 1. Okay, so see if you guys can do the same type of thing in this U-try question. Press pause and try it by yourself before you look at my answer. Press pause. Okay, let's see how you did. It makes sense for us to start by finding side B, using b squared equals a squared plus c squared minus 2 times ac times cosine b. This is the work we get. I ended up with b is about 7.5. Now, this makes me super nervous to round to the nearest tenth, because do you see what we're chopping off? Like it was 7.545, blah, 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 blah. And technically speaking, that means we're going to round to, if we're running the nearest tenth, that's 7.5, but we're chopping off like a major chunk there. So that just makes me a little nervous, okay? Which we'll discuss in a second. So then I decided just to go in alphabetical order, and I used a squared equals b squared plus c squared minus 2bc cosine a to find that the measure of angle A was 52 degrees and the measure of angle C was 80 degrees. So if you did that work, that's what you'd see. But again, you don't have to choose A. Maybe you chose to find angle C next. And then what you would have done is you would have used this formula instead. That you would have used a squared plus b squared minus 2ab times the cosine C instead. And you might be upset because you got answers that were a little bit different. They're close. They're like 0.3 of a degree off. And like, but remember, a degree is like tiny, 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 tiny. So we're off. We want to be as exact as possible. But again, as long as you show your work, I'm okay with either one. The reason that we're getting these discrepancies, if we did it from one way or the other, is because there was some obscene rounding that was going on here. So that's kind of why. But if your answers are a little bit off like that from the answer key, it might be because of a rounding issue and you used a different equation than I did. So either would be okay with work. The discrepancy is due to rounding. If you have any questions, feel free to message, okay? But hopefully that U-try went well for you. Oh. Okay. So let's try a different one. Solve triangle ABC with side A is 19, side B is 26, and side C is 31. Well, obviously, we can't have the law of sines here because we don't have any angles to write in a ratio. So we can choose any side. It doesn't matter what side we pick. Most of the time, people pick A because it comes first. So I'm just going to do that since I can't ask you what you want to do. But again, you could choose any of these to use first. All right. So I'll just use A since it's first. So I'll say A squared equals B squared plus C squared minus 2. I'm going to use these two guys on this side, BC times the cosine of A. And then I'll just put everything in. So 19 squared equals 26 squared plus 31 squared minus 2 times 26 times 31 times the cosine of A. Now remember, again, our goal is to get this cosine of A by itself, but this is still the coefficient, so we can only move over, I should say we have to move these over before we even think about dividing, okay? So remember, the biggest thing I see with the law of cosines is that people don't listen to me, which is so sad because I give good advice, is that they try to take this whole thing. You can't do that, guys, okay? So I know it's faster to do it that way, but it's wrong. So, all right. So we're going to take 19 squared minus 26 squared minus 31 squared. That gives me negative 1276. Then I have negative 2 times 26 times 31. That's negative 1612 times the cosine of A. So now I see that I could divide negative 1276 by negative 1612 to get about 0.792 is the cosine of A. Again, to isolate A, what I'll do is inverse cosine that result, and I end up getting about 37.7 degrees, okay? Again, I'm not, I didn't inverse cosine 0.792. I always use the whole decimal whenever I can. Oh, oops, measure of angle, 37.7. Measure of angle A is about 37.7 degrees, okay? we only have one angle. So we can't use the triangle sum theorem until we find another one. So let's find maybe one of the other ones. Again, we can go in order if you want, and we could find B. Oh, we could find B. Again, it doesn't matter. So if I do B squared, that's going to be A squared plus C squared minus 2AC times the cosine of B. Again, hopefully, if you write the formula out each time, you guys, it's going to help you memorize that pattern, because of course it's not going to be given to you, okay? Because it's just a little quiz on this material. And then we can put these in. So 26 squared equals 19 squared plus 31 squared minus 2 times 19 times 31 times the cosine of B. Again, let's remember to move the terms over. And then we can leave this coefficient here. And then I can get the numerical results. And again, going forward, like, it's fine with me if you end up kind of saving some steps. And if you take 26 squared minus 19 squared minus 31 squared, get that answer, and then divide it by, the only thing is you have to put it in parentheses, -2 times 19 times 31. Like, I'm okay if you skip that step and then just jump right to like 0.548 is about cosine of B. But what I don't want you guys to do is to take the this and then to divide it by -2 times 19 times 31, because do you see how it gives you something totally different? You have to have that whole thing in parentheses. So because I've seen issues with that in the past, in addition to calculator issues, that's why I usually am suggesting that you write these numbers down so that you're not tempted to like to do incorrect things, okay? So to make sure I have that value in the calculator and I'm not using the rounded value, we could do that as well. And then I want to take the inverse cosine, and that gives me that the measure of angle B is about 56.7 degrees, okay? And again, we're having fun, so we could do the same thing with C squared if we wanted, but why not use the triangle sum theorem? So we could take 180 minus this 37.7 minus, what was this guy? 56.7, and that gives me the measure of angle C, which is about 85.6 degrees, okay? I didn't figure out what it would have been if we had found, well, I found C first this time in a different attempt, and I still got the same values. So I'm thinking that the rounding wasn't too bad this time, okay? So why don't you use example 2 as a model and try this you try question, okay? See what you can do. Okay, let's see how we did. So first, I figured you guys would choose A. It doesn't really matter, but I chose A, and I got that A was about 60.7 degrees. Then I decided to spruce things up, and instead I chose angle C to find next, and that gave me about 34.1 degrees. Oops. And then angle B was 85.2 degrees. And I believe even if you used B squared equals A squared plus C squared minus 2AC times cosine of B, you still get the 85.2 degrees for angle B, okay? All right, so that's how we use the law of cosines to help us solve right triangles. Well, sometimes we don't need to solve a whole triangle. Sometimes it just wants one different piece of it. So example 3 says the lengths of the sides of a triangular plot of land are 120 feet, 150 feet, and 175 feet. Which is the largest angle of the triangle? Well, we've discussed this a little bit earlier in the unit. The largest angle of the triangle is going to be across from what? That's right, across from the longest side. So instead of having to use all 3 versions of the law of cosines, let's just use the one that's going to help us find the largest angle. So we're going to use the largest side. Well, our largest side is going to be this 175 feet. So let's use that to help us set that up. And they didn't name it A, B, and C. That's okay. So we'll have 175 squared. That's the largest side. And you could draw and label a triangle if you want. Equals 120 squared plus 150 squared minus 2 times these other two sides times the cosine of, I don't know, let's call it A to be super creative here, okay? And then we just go to town from there. We know that then we would subtract the other two terms, and then we're left with the -2, 120, and 150 cosine A on that side. So kind of like I did in my work here, I'm just going to try to save a step, and I'm going to take 75 squared minus 120 squared minus 150 squared, put all of that on top in parentheses, and then divide it by -2 times 120 times 150, okay? And then that gives me I put 75 squared. 175 squared minus 120 squared minus 150 squared. Helps if you type things incorrectly, doesn't it? Okay, and that gives me about 0.174. That doesn't make sense. No, it does make sense. I was just thinking that it had to be obtuse, but it doesn't have to be obtuse to be the largest angle. I'm hallucinating over here. All right, so we get that -0.174 is about equal to the cosine of A. So if I take the inverse cosine of that answer, I get that the measure of angle A is about, and if I'm rounding to the nearest tenth, this 6 tells us to bump the 9 up to basically like a 10. So this means that this is going to be about 80.0 degrees if we're rounding to the nearest tenth. Notice I didn't just put 80 degrees, I put 80.0 degrees if the instructions, which would be on a quiz or test situation, tell you to round to the nearest tenth, and that's what we've been doing, okay? Oh goodness, all right, so one more for you guys to try, okay? See if you guys can just use the law of sines to find this specific angle. Scientists can use a set of footprints to calculate an organism's step angle, which is the measure of walking efficiency. The closer the step angle to 180 degrees, the more efficiently the organism walked. Find the step angle B for the set of footprints shown. So see if you can use that information to set up the question. Okay, how'd we do? This was the one that had the obtuse angle. Sorry, I was confused before. Again, the reason I knew the other one wasn't going to be obtuse is because I'm taking the inverse cosine of a negative. And I know if I'm taking the inverse cosine of a negative, I'll get an obtuse angle. So this is the one I was thinking about. I apologize. But this is the work that you need. Since 335 is across from angle B, we would set that up on the left-hand side by itself, and then use our law of cosines to help us out. So that's the law of cosines. So now we're able to solve triangles, like any type of triangles, given any sort of information. So that's really exciting. So at this point going forward, now you need to think about what you would do and distinguish between whether you can set up a ratio and start using the law of sines, or if you're stuck and you have to use the law of cosines. Okay, so the law of cosines is a little more work, but it's still not too bad. Okay, so good luck, have fun.